For this course, you won't be required to learn how to perform the simplex method by hand. In this video, we'll go over one online simplex calculator that can be used to calculate linear programming problems. Let's imagine we were given the constraints 3x minus 25 plus y plus 2z is less than or equal to 0. Z is greater than or equal to x plus y minus 12. 4 times the quantity x plus y minus 30 is greater than or equal to 0. 2x is less than or equal to 3z. X is greater than or equal to 0. Y is greater than or equal to 0. And z is greater than or equal to 0. And let's suppose we were told that our objective function is to maximize 7x plus 5y plus 6z. We'll be using the website PHP Simplex. It begins by asking us which method we want to use, and we'll stick with Simplex method. The alternative of graphical locks us into just 2 variables, and here we have 3. The next question it asks is how many constraints we have. Here we have 1, 2, 3, 4, 5, 6, 7 constraints. However, these last 3, x greater than or equal to 0, y greater than or equal to 0, z is greater than or equal to 0, are standard for simplex problems. And when using this technology, we wouldn't count these for our number of constraints. Meaning for this problem, we have 4 constraints. As we continue, the first thing we might notice is that our variables are named differently. This website uses x1, x2, and x3 as its standard. I'll go ahead and rewrite our inequalities with this change of variables. At this point, we can enter what our objective function is. Here, maximize is exactly what we want. In our objective function, we can go ahead and enter. The next thing that we might notice is that there's a much more structured arrangement of their constraints. Because our constraints are not currently ordered in the same fashion, I'll do that now. At this point, we can enter our constraints. You might need to change the direction of the inequality. When we begin, it walks us through some of the steps of the simplex method. To actually perform the simplex method involves steps that are more involved than the conceptual overview already talked about. However, for those that are interested in learning what those steps are, this resource walks you through the independent steps of using the Tableau method. Until it finds the optimal solution. Here, it also gives an option to view the optimal solution as a fraction. For those that don't want to see those extra intermediary steps, it gives the option to go directly to the solution. Translating the solution back to the variables as we were given in our original problem, we would say that x equals 0, y equals 49 thirds, and z equals 13 thirds, and that the optimal value was 323 thirds.